Hey everyone, my name is Matt Fisher, and I'm one of the core maintainers of Draft, an open source project designed to make it easier for developers working with Kubernetes to streamline their development process. Today, I'm going to show you how to run Draft with Azure Container Services and Azure Container Registry. Before we get started, I wanted to talk a little bit more on what is Draft. Draft is a new open source tool that makes it easy to develop container-based applications and deploy them to Kubernetes clusters without knowing much about Docker and Kubernetes. Draft is a perfect complement to cloud services like Azure Container Services because it will enable you and your team to focus on building just the application while leaving the infrastructure management and deployment up to Azure. You can use Draft with any Docker image registry and any Kubernetes cluster, but this tutorial will show how to use Azure Container Services and Azure Container Registry to create secure and an efficient development workflow. To start, we're going to create a new resource group for the project. Let's call it Draft and deploy it to the West US2 region. To do that, run az group create. We'll give it the name Draft, and we'll put it in the location West US2. Now that's done, we're going to create a new container registry in this resource group. Draft will use this registry as a private repository for Docker images that Draft will create. So to do that, ACR create. We'll give it a name of Draft on ACR, and we will deploy it in the same resource group that we just did called Draft. Give it an SKU of basic, and then the location will be in West US2 region as well. And we will enable the admin account. So then Draft is able to communicate with this container registry. All right, now let's copy the credentials to the clipboard so we can give Draft all the information it requires to communicate with this registry. On macOS, we can copy this using the pv copy command. So what we'll do is ACR credential show with the name Draft on ACR, the name of the container registry we just created. And then we will grep for the name. So then we are skipping out on the table information. And then we will use awk to print out the first password. Skipping the name, and then pipe that to pv copy. Now that we have the credentials, we're ready to create an ACS cluster. So let's create it using ACS create and give it a name as well. We'll call it Draft Demo, and we'll put it in the same resource group, Draft, and give it an orchestrator type of Kubernetes because we're deploying a Kubernetes cluster, and the location is West US2, so everything is all in the same region. All right, so this will take a little bit of time, so I will cut out the screen at this point, and then I will see you back when this is finished. All right, let's grab the credentials so we can communicate with this Kubernetes cluster. Use ACS Kubernetes get credentials, and we'll give it the name Draft Demo and the group Draft. We'll use this so then we can communicate with the Kubernetes cluster in the next step. So now that we finally got the Kubernetes cluster up, the Azure Container Registry is up, and the group has been created, now we can do draft init. So let's do draft init, and we will let it initialize draft itself, and then we will give it the credentials it needs to connect to the Azure Container Registry. So we will do draft on acr.azure.cr.io. The username is the same name as the Azure Container Registry, so draft on ACR, and the password. All right, so now Draft has been is inside the cluster and is available. So now we can just let it install, and once that's done, we can now see Draft is up. By doing that, we can do a kubectl namespace of kube system get pods. or let's just, get deployment. And we'll see that there is a draft D deployment available here, and we can see that the desired and current amount of pods available is 1. So it's up and running. So now we can actually start running applications on this Kubernetes cluster. So let's start with an example Node.js app. So you can see here in Visual Studio Code, I'm open to a very simple Node.js application that has an index.js. And all it says is, hello world, I'm Node.js, and it just has a package.json to run the application. So to start and run this application, what we can do is we'll do a draft create, and we'll give it an application name of hello world. And then you'll notice that draft detected the programming language available in this application, and then notice that it was JavaScript with 75% certainty. And then when we did draft create, it created a bunch of stuff that was very it bootstrapped the application with a Docker file, a chart, which is for Helm, and a bunch of other context around draft to give it a name, which namespace is going to be installed in the Kubernetes cluster, and a couple other nice features for draft. But what we want to do is now we'll do a draft up and deploy this application. So you see that the draft up is started and it's building the Docker image, and we will come back again once this has been built and deployed. All right, so we can see that the application has been built and deployed to Kubernetes. It took about 2 minutes for the very first time to deploy, but every single subsequent deploy should be much quicker thanks to Docker image cache layering. But before we actually go and check the application, let's check the logs and confirm the build logs and take a look at that. So we can do that with draft logs. Draft logs will show you all the build information that was from the previous one. So we can see that it was building an npm or doing an npm build install, and then doing an npm start or not starting it, but setting the runtime command to npm start, and then tagging the image as draft on azurecr.io, hello world, and giving it a nice unique SHA. And so that image was pushed to the Azure Container Registry when we ran draft up. So let's verify that, as we've seen there, but we can do an Azure or AZ ACR repository list, and then we'll give the name of the Azure Container Registry draft on ACR. And we get that response back from AZ ACR, and we see that there is a hello world repository that was created in there. So our application was pushed up and the Docker image is available there. And as well with this application was deployed to Kubernetes. So if we do a kubectl get pods, we'll see that there is 2 pods available and running for this application, and we can connect to that. So we do a draft connect. So then we can get a tunneled connection to this application running locally. So you can see there is a URL here for localhost. We'll copy that and open up Safari. And then we'll put that in the browser. And we'll see there is a hello world, I'm Node.js response coming back from it. We can refresh it a couple of times. And you'll notice that inside the application, we got a couple of hits here. This application isn't actually running locally here, but this is running inside the Kubernetes cluster. We're just creating a local tunneled connection over to it. So that's awesome. Now let's go and make a small change to the application and iterate on it a couple of times. So we'll go to the index.js and we'll change it. Instead of saying, hello world, I'm Node.js, why don't we say, I'm being deployed to Azure Container Services. Save that file, and then we will do another draft up. And you can notice this time, the application only took 16 seconds to actually build. So the first time took 90 seconds for it in the build stage. This time took 16 seconds. And this is, again, thanks to the Docker image layer caching. We didn't actually have to pull down the entire Node.js runtime a second time. So the application has been deployed, and we can see in kubectl get pods, we'll see that the old ones have been destroyed and they were rolled out, and the new ones are coming in. and so they have an age of 18 seconds. So now we can do a draft connect again, and the application is available on this URL from this new tunnel. And if we open up that new one, we'll get hello world, I'm being deployed to Azure Container Services. So what we did was we rolled a new version of this application on top of Kubernetes, and we didn't have to really know or care about the underlying infrastructure. Draft just handled the deployment to Azure Container Services for us. And so there we have it. If you would like to know more information about Draft, please go to github.com/Azure/Draft and let us know. Thank you.